Hello students, our today's topic is hidden surfaces and line removal method. Whenever we want to display any graphic image, especially 3D graphic image, the realistic graphics, displaying the realistic graphics is a major concern. That here the major concern is how we can remove those part of the scene that are not visible from particular viewing position. Many algorithms are available for removing the part of the scene that are not visible. So those algorithms which are helpful for removing the part of the scene that is not visible are referred to as hidden surface elimination method or visible surface detection method. Selection of any method for particular application depends upon various factors. That what kind of object we want to display, what are the available instrument, what is the complexity of scene, and next one is whether the scene is static or it is an animated scene that is to be displayed on the 2D surface. Hidden surface removal method divided into two categories. One is the object space method, the another one is the image space method. In object space method, it is implemented in physical coordinate system, and image space method is implemented in screen coordinate system. What I mean to say here is, in object space method, we compare various objects of the scene and the parts of the object to determine which part of the scene are visible or which are hidden from the particular view position. Backface detection method is one of the object space method. Image space method, in this we decide the visibility of scene pixel by pixel on the projected plane. Most of the hidden surface detection algorithm use the image space method. So the first one is a Z buffer method, that it is a image space, it use a image space approach. The basic idea of this test is the Z depth of each surface is to be determined. In this method, each surface is processed separately. Every time we have to analyze one pixel position, and according to that we have to calculate the depth value. It is simple and efficient method. This is image space method that is used to remove the hidden surfaces. This method is also known as depth buffer method. So in this method, what I have told you, that we have to find the depth of each pixel position, and that depth is to be compared on the, that is to be displayed on the projection plane, and each surface of the object is processed separately. This algorithm can be applied to planar depth buffer used to store the depth value of each xy position, and refresh buffer is used to store the intensity value of each pixel position. For each pixel position, if we know the depth value of one pixel position, and then we can calculate the depth value of the pixel position horizontal to that particular pixel position or vertical to that particular position. So Z buffer algorithm says that we have to calculate the depth value of every surface on the object of that particular object, and accordingly we have to update the value of Z based upon the previous value of Z and newly calculated value of Z. So Z buffer algorithm that we have already discussed, that is, it is basically image space method. So it is very simple to use, it is very easy to implement. It is implemented both on image space as well as the calculation procedure is implemented on image space method, and it reduces the speed problem if implemented in hardware. It processes one object at a time. Even with the number of polygons, it can be executed quickly. It is very easy to implement Z buffer algorithm. It requires large memory. It is one of the drawback of Z buffer algorithm. So depth value and refresh buffer value, every time we have to calculate the depth buffer value, every time we have to calculate the refresh buffer value for all the pixels of particular object that for which we are finding the hidden surface, and we in which we want to just want to remove the not visible hidden surface before displaying on the screen. So we have to calculate the depth value and refresh buffer value. That requires lots of memory. So this is the one of the disadvantage of this procedure. Without additional code, it cannot work for the transparent surfaces. So for if we want to implement it for the transparent surfaces, we have to revise that particular code, and it is also a time consuming process. Thank you.